Here we go. You can see there's a bunch of stuff. I put this together piecewise and then said, well, now how am I going to organize it? See, there were some things I thought ought to be in there, and they didn't necessarily go together or whatever. So I've been shuffling around stuff here, but the facts are still straight out, but the ordering is you can either appreciate it or not. So I'll just start out because, I said, well, introduce the speaker. Yeah, well, I don't know. I'm not a speaker. This is not like a speech, okay? Really. You got a problem or don't understand something about it? I'll start with undergraduate, right? Well, no, I'll start. I grew up in New Jersey, like that. Leonia, New Jersey. It's right outside Englewood and a stone's throw from Manhattan. And my father was a geology professor at Columbia. I went to Brown as a chemistry major, class of '64. Then I went to Minnesota on the advice of, you'll see there are a couple of important individuals here. Arriving in Minnesota, I found that actually the 8 faculty members from the department were thinking of leaving the department, including my advisor. So I met my advisor who told me that he was going to go down to Australia for a leave. There was a quarter system. So, yep. And I should be looking for places to go, like, why don't you just apply to Columbia? So that's what I did, and that's where I ended up. I took some really useful courses at Minnesota, though. One that kind of sticks here is this computer programming. Control Data Corporation was the purveyor of local, of the computing stuff. And, you had to, I did a change, remember, I could make change, write a program to make change. Learn Fortran, learn Octal, stuff like that, And that stood in good stead. But of course, it took a whole day because you had to submit them, and then it would come back the next day. So I don't know. I went to Indiana Field Camp. I was only in Minnesota 1 year because my advisor left. Columbia 1965 to 1975. So I was at Columbia, Lamont for 10 years. I got my PhD in 1970. We'll have a reference to that. And there's some observations that, So right away I would say the reason why I even ended up at Minnesota to work with Paul Gass was because of Wally Broker. So those are my two people who more or less asked me, what do you think you're going to do? And I never had an answer. I said, well, why don't you go to grad school here? Why don't you go to Minnesota? I said, yeah, fine with me. And then, of course, I came here in '75 with Sue. Sue and I came together. And for that, I can thank Jack Oliver and John Turcotte. I also thank Sue. She didn't get me to Cornell, those two. Oliver came from Columbia. There were already Columbia Lamont people here, right? Brian Isaacs, for instance, and George Haig. So it was like little Lamont, but Lamont was kind of a mess at the time. So Oliver left. Okay, so that's my history, because I'm not going to tell you what I did at Cornell. Right. So what's my research? Well, recently I was made fellow of AGU. So it said this is a neutral party, or maybe it's someone with an axe not to grind. Fundamental discoveries about the mantle and continents based on mid-ocean ridge, oceanic island, and arc magmatism and continental delamination. So there seems to be everything. I can't think of any tectonic regime that's embedded there. And it's mantle and continents, aside from the ocean crust, well, okay, what else have you got? So the oceanic crust was a difficult thing to study because there were very few samples, including this one here. Ken DeFay's guy at Princeton went and dredged offshore Gore to Juan de Fuca Ridge. This is the iconic magnetic lineations off the coast of Pacific Northwest. So I had Juan de Fuca, Gore to Rise samples, all basalts, some of them actually more iron-rich than others, but it's just a petrologic kind of problem. And so what was known about them was there was some rare earth analysis, but actually what happened was, in preparation to go to the moon, it was very important to have the analytical capability to analyze rare earths, because they were a big deal. Haskin and Fry and sort of they'd analyze some, but what Gast said was he had been collecting from various people's bags, including DeFay's, including the ones from Lamont that Ewing dredged, including Engel's stuff from the East Pacific Rise. That was about it. I mean, you know, you needed the rocks, you can't make it up. So I just analyzed the heck out of them, rare earth and barium, over and over and over and over. I can't believe I analyzed so many times. But there they were, ready to do it. If there were only a limited number of samples, you could more or less do all of them. And that's basically what happened. And then, this was 1965, well, the plate tectonics revolution. So obviously, you can make the statement that you're doing something that has bigger implications. You're analyzing small areas in 3 parts of the mid-ocean ridge. But the rest of the two-thirds of the surface of the Earth that's what's underneath there. So, and you couldn't say that before. Or maybe if you went on a limb, if you started saying it in 65, but not in 70. So we, and this is Paul Gast and Norm Hubbard, who was a postdoc with Paul, and I said, well, we're going to just write a comprehensive paper. We're going to do the petrologic part. We're going to do the geochemical part without the isotope, and see, you know, what we can say. So that was the paper in JGR. Now we know a lot about the paper. At least I'm taking back in my memory, because in 1986, it'd been 16 years since it was published. We've been cited over 400 times, which is actually a lot for the time. And so the current contents editor, a guy named Garfield, every week chose a paper to be a citation classic. After 10 years, it's a classic. Holy mackerel. So I said, oh, and more or less, he said, this week in the contents journal, if you will, it's going to be this paper, and it's one a week. So there are not that many around, actually, although it's started to double up. It's unclear kind of how many there are. There are either hundreds or thousands, but there are millions of papers. So, okay. So here is current comments, and it started in 1977, and Garfield, you know, wrote a little thing on it. I'm not going to have enough copies for all this, but maybe, you know, you can just kind of pass it around and share half of them. So I'm not asked you to read it. But he says, hey, I want the human aspect of this. This is a comment thing. It's not, well, why did you think it was a popular paper? Why? And did you run into anything that people might want to see? So it was not a scientific thing at all. It was kind of a ambient kind of thing. So what happens? The Citation Classic format was to write a couple of nice paragraphs about your thing, answering those questions very specifically. And this is what I wrote, which is so short that I didn't even just even kind of read it. Right? First of all, ocean ridge basalts, I didn't call them morgues, I called them ocean ridge basalts, that was the first thing, are the least accessible, but in many ways the most important rocks on Earth. We use novel geochemical data. Rare earths is novel data? Yeah, sure. 1970, yeah. Quickly accepted theory of seafloor spreading to construct a model to explain the origin. And it says, in 1970, article came at the crossroads in the earth sciences in the mid-60s, the concept of seafloor spreading, unified terrestrial geology, and there's a lot of people doing stuff at Lamont on this, so it was a good environment. And the ocean ridge basalts took an importance undreamed of about only 5 years before. this basalt comments magma on Earth, 6 kilometer thick crust in the oceans. Okay, so Paul Gass, my thesis advisor, had been looking for these rocks and said, we got to get moving on this, because this is something that other people got some rocks too. And Engel had done some of this at Scripps, and Fry and Haskin had a rare earth paper in JGR, but they didn't really talk about the origins. So I put the petrology in there, and we had all these analyses from East Pacific Rise, Gorda Wandapuka, 30 degrees north, Mid-Atlantic Ridge. And that great foresight was, required to actually get those samples, because it wasn't really, people didn't know what to make of them. He said, oh yeah, there's Hawaii, that's in the middle of the ocean. So what? So you dredged a young rock. This is obviously a young rock. So.
Can you pass around the rock?
Yeah, right. Yep. And Miyashiro, he's the metamorphic petrology guy. Ewing said there's something up here, and he got Miyashiro to come to Lamont, and Miyashiro was looking at them petrologically and petrographically and doing mineral analysis and stuff, which we didn't do. But he didn't do any trace elements. So I went and talked to Miyashiro, or I talked and Miyashiro listened and didn't say anything. It was incredible. I had to excuse myself at the end, just saying, well, I think maybe I should go. But anyway, those were the same samples that we analyzed the rare earths. And some of the topics that we covered having to do with magma segregation, primary magmas, creation of large-scale compositional heterogeneity in the mantle. Well, we had an opinion on those. I mean, I like it now, but we went out on a limb. Hey, you got a whole bunch of data, do it, right? Don't wait around. So, and then there's the lunar stuff. Well, the reason why I was a NASA fellow, and the analytical techniques were to analyze lunar rocks. They weren't to analyze mid-ocean ridge basalt or alkali basalt, which I did a whole bunch of, and that was my thesis actually. So the Gass went down to Houston, set up the lunar receiving laboratory in Houston, and Norm went with him, and I kind of covered the whole thing as an acting assistant professor, and then Gass died, actually, 43 years old. Died. So that was kind of when I went to UCLA for a year with Sue, and then came here, and that's forever, still there. So that's kind of what it says, right? And it says, did you run into anything, that was kind of unexpected? Well, yeah, they had these galley proofs. They were completely the wrong version of the paper. It's like, fix the galley proofs, holy mackerel. It was just a mess, the whole thing. So that was a surprise, right? And so I actually went down to the lunar receiving laboratory a couple times, and Shen Su's son was there, who I should point out is a really important guy. He was at Lamont. There's a lectureship in Goldschmidt on Shen Su, right? Or Shine Soon. But once he figured out that was kind of, he went back to Shen Su. Wally Broker gave all of the Taiwanese Chi-Yu-Shi called Charlie, which is very unfortunate, and stuff like that. But it was all sorted out. Okay, so that was how I know kind of what I was thinking, in case I'd forgotten, is I actually wrote it down. Right? Now there's one other citation classic in the department here, and that's Jack Oliver and Brian Isaacs. And they found the Tonga seismic zone and identified it as a slam. So I don't want to paraphrase what they are, but actually Jack writes a nicer thing than I did. But Jack has a book on himself, etc. So I owe a lot to Jack, and I owe a lot to Wally and to Paul, and Don Turcotte I should mention, because when we got here, he was very, very supportive kind of guy, and we went out to lunch with him every day of the week. So that was nice too. Okay, so what about, so that's the mid-ocean ridge thing. I never analyzed another sample from the mid-ocean ridges at all. Analyzed a bunch of ophiolites, which are supposed to be mid-ocean ridge, but in fact, structurally they look right, but geochemically a lot of them are wrong. They're just not ocean. They're arcs. But at any rate, okay, so that's that. And right now that's got something like 510 references or citations. And in 1986, it already had 410. That's only 100 in the next 15 years. That is a burnout. I would call it a burnout. And what could you expect? You write a paper, it's supposed to go, right? You go down to nothing. Well, this one did it. I think it had one reference last year. You know. So, current contents. Let's just say these are the score sheet. I tried to find, there's a list, Garfield has a list. And I'll just ask, you know, for recognition factor. Hatton S. Yoder. Anyone know Yoder? Yoder. Oh, he would be so unhappy. He's a geophysical guy, he's an experimental petrologist. Ross Taylor, Australian guy. Mike O'Hara, experimentalist. No?
I think it's just the list of most.
Actually, this is the 16, the Garfield list, because most of them are biologists. I mean, you look at the published literature, Earth Sciences is a really low percentage. So this is, as far as I can see.
Like the highest cited papers in each field? Or
No, it's not just that. Somehow it's deemed, that helps certainly. Somehow they made this mysterious choice. They're not really saying how. All right?
Okay.
It does help to have all that citations, yes.
But it's just one journal, or?
No, the whole thing, all the published literature of science in the whole world.
It's weak citation class. Okay, who's putting out the weak citation class?
Yeah, this is current contents.
Okay.
Current Contents was kind of a journal which published lists of published papers every week. All right? So
That would be useful. Or was it not useful?
they stopped it. It was too useful. So here's, okay, O'Hara, there's us. Holloway, experimental petrologist. Onions is the guy who was hired at Lamont after I left, or coinciding with my leave. Geophysics, Vine, Fred Vine. Huh? Okay, we're talking seafloor spreading here. Manabe, well that's an atmospheric science guy, right? Oliver, Hertzler, Broom, Taiwani, these are all guys at Lamont. And then low temperature, Garrows, Brooks, Shackleton, was at Lamont at the time, I should have started. And then there's this guy, Berner.
Wait, what? Your brother-in-law to Berner?
Yeah.
Really?
Yeah.
Yeah?
Yeah,
Is that Sue's brother?
No.
Oh, no, different.
No, my sister's husband.
Okay.
Yeah, right. I can
Your
get,
sister also a geologist?
Yeah.
oh, what?
A geologist?
Your sister?
Yeah, she's a geologist.
The family trade, Bob.
There's a book.
Whoa.
We wrote a book together.
And she goes by Berner too?
Is it Berner, like Berner and Berner?
Berner and Berner.
I thought they were siblings.
That would be incestuous. We don't. Oh my God. That would have never occurred to me. Never occurred to me. And the Bob Berner got his citation classes for a book, actually, which is this one, Early Diagenesis, and he has a little write-up here about why he thinks he got the thing. It wasn't because of maximum number of citations, because
And he
the
only had
book.
270 at that time.
Well, I'm just saying,
Right.
well, Holloway only had 90.
I know. How did he get through?
But it is, so the criteria are a little murky, all right?
Yeah.
But Berner, who was in the, he died, he was in the National Academy, and they said this was because he used a mathematical approach, or theoretical approach is what he said. So what I did, just to push this forward a little, and I took the citation stuff for a bunch of papers. And I gotta believe, since I was kind of responsible for everything, that in some sense every paper that I wrote might have a connection. But there's some distinct connections. And so I just chose 6 of the papers with maximum number of citations, and just to see, you know, that, yeah, they covered the material. So I guess they kind of were right. The one, Ocean Ridge Volcanic Rocks, has 513 as of last week or something, and it's just limping along. And the first one there, delamination and delamination magnetism, has substantially more than twice its number, and that's still going. Now, I mentioned being a burnout. Of the 6 papers that I, you know, chose, so to speak, just to have a look at it, this is a little surprising in terms of what happened here, is I took the 6 papers, and these go from 1970 to 1993, and the last one is what I'll call the delamination paper. Now, I was chided, or maybe you didn't know, by Judy downstairs for using too much stuff.
No, we all are. Don't worry, Rob.
Okay, we know. I think I know what they are. The only one that's not there is one that I would call Andean Adatites, 3 ways to make them. I really, I'm proud of that title. I don't know about the paper. Yeah, right. So anyway, of the 6, there's an alkali basalt one that has analysis of this thing here in it. This is a potassic alkaline basalt from the Lucite Hills. It has lucite in it. Wyoming. So Wyomingite. That's surprising.
Can you pass that one around too?
Yeah. It kind of looks like a schist, because all of the blankets are all oriented from flow. And it's platy, showing it flowed, right? Okay, now I said a burnout. 4 of the papers, including the one with the Citation Classic, were I would call burned out. They're burned out. After 15 years, right? There's 2 of them that aren't burned out at all. In fact, they started out just kind of, you know, limping along. And for some reason, and I think I kind of know what the reason is, they started getting more and more and more citations. So instead of going whoop, they went whoop, and they're not done yet. Last year was, and the previous year, the highest. Well, yeah, so there are people, Garfield being one of them, kind of look at, they call them, what was his phrase? I have it here. Immediately successful, as opposed to sleeping beauties. You wouldn't believe that these guys with the, I mean, seriously. No, seriously, that's what some people, or DR, or delayed recognition papers. So what happens is all of a sudden concepts of slab melting came into vogue, and everybody had to have a reference, so they just threw in the 78 paper. They're still doing it. I don't want to stop them. They're doing it. The second one.
The next promotion.
The second one is delamination, which has also become very popular, and you can tell that just by looking at either Google citations or ISI citations. You can look at both. They're actually different in the sense that the numbers are different. The Google thing everyone uses because it's got many more citations than the
Then how are those metrics? Shouldn't they be the same?
No, because unless you really know the mechanics of how they're doing it,
right,
you don't know
like
what.
No.
Maybe the New York Times is good enough for them, or I think a journal. I don't know. I hope not. But
Sometimes it's
Right. Oh, do they
yeah. So
citation?
don't take the citation numbers as being fixed in something. So the reason why I think there's more than just somebody waking up and saying, "Hey, this is a good, okay paper," is that the whole community woke up, and the total number of citations has gone up exponentially for both of those, and it's still going. It's going to stop sometime. It can't go like that. So that was just something, you know, when I said, oh, well, we'll just play around here. So that's what I've been doing some in the last week, is to play around, and that's that. And then you can see that if you wanted to know what's in the paper, I'm not going to do that now. Some of that verbiage there has got a figure from each one of the papers. And I guess the thing that I would take away is, draw a picture, show me a picture of what's going on, right? The picture can be wrong, but you know, it brings it somehow into view more. So there's a picture of every one of them, and the one for the delamination one is kind of a short story here because it sues, basically. But I was on sabbatical over in Paris, and I wrote the thing about delamination magnetism. And the adachite part, because it's a heavy rock, meaning it has a garnet, planocurcine mineralogy, which the trace elements tell you. And so that one had, that's how it came about. And it was just the right time, because I can say that everybody had andesites coming out of the mantle. And I had an andesite coming out of the mantle. That was the slab melt. But most of the stuff comes out of the peridotite. It doesn't come out of the slab. Part of it may come out of the slab, but not the whole thing. So the 6 papers, you know, they found the thing, and the two odd ones, which were the delayed ones, or the Sleeping Beauty ones, are kind of fun because if you just Google Sleeping Beauty and Garfield or something like that, you can get an idea that he says that these are really infrequent. Well, what's really infrequent is to have no citations for 5 years, and all of a sudden have 200. Or the other thing that comes, if it's fake science, and somebody calls you out, way it goes. And that's the cold fusion, and also the water thing, polywater we call it, and the whole thing, infinite dilution. There are these hoaxes that are around.
There's also the arsenic thing, or there was some, what was it,
arsenic-based life forms.
Yeah, arsenic-based life forms.
Okay. Well, arsenic's a rare element, except for when but anyway, yeah. So those can have an immense number of citations to be given, in particular cold fusion. And then in 2 years, it's gone. And the ones that are saying it are saying, this is an example of freak science. Well, presumably none of this is freak science. So anyway, that's that one. Now, what I thought I'd do, because I don't want to go into detail on all this kind of stuff, is just say the Island Arc thing was a longer project. It wasn't like a one-off like the Meadows and Ridge thing. And it involved a whole lot of students. It involved Sue and I. It involved Mike Turpin, who was down in Florida when he was at Columbia. So I thought I'd just, you know, say the kind of things that happened there in the field, just because you got to have the rocks. You got to go and get the rocks. How do we get that rock? Doug Coelho was an undergraduate. He went up with me to ADAC. He's also a runner, so he won the half marathon on ADAC Island. But also, we went by and the sun was out. Huh?
How many people were in the half marathon on ADAC?
Next question.
Yeah.
Okay. Not many. Oh, well, you think I didn't.
Did you get in second?
No,
No,
they
Sue
were
was
more than
second.
2 people. Okay. So this was on a Dagdag volcano. There's Moffat volcano on a Dagdag. This one was active post-glacially. Because this is a lag deposit with it looks like beach boulders in it, but they're not beach boulders. They're rounded pieces, because there's a selvage of basalt on the side that are coming up the conduit, probably blasted by volatiles, and erupted, and it's a pyroclastic unit, and these are the heavy baggage for the pyroclastic unit. And so I told it to Doug. I said, you know, well, we didn't even know these were there. I said, look, the sun's out, which is good because you get a cleavage reflection. When it's a cloudy day, today would be a very bad day because, in fact, it looks like the Aleutians today. So he comes back with this little scrap, like just a single crystal there. I said, oh man, oh, it's probably epidote. Ooh, it's awesome. So I took out and I put it right there. He said, well, how about this one? With that one, oh my goodness. So we got 100 pounds, and I sent it in a lobster container with the U.S. mail for $7. They refused to take anything over 70 pounds, so I had to break it in half. The other half, never. So that one is a xenolith, and a whole bunch of other xenoliths representing various stages of crystallization of the magma that finally came out. So it had to differentiate at depth because of the mineralogy telling you that, and we had the samples. And there are other geologists that walk by that thing and just didn't even notice it. So basically you gotta be on the ground even, sometimes you miss them. Goodness knows what we missed, so anyway, that meant, what were we up to? Well, we really were not up to, and none of the proposals said we were gonna do young volcanoes. No, it's heavy, right? Believe me. And so we were interested in the volcanic plutonic history of the island. It's a historical thing. So we went to the southern part of Adak Island, and here's a picture of the southern part of Adak Island. You notice the scale there. It's 10 kilometers. There's a pluton down there. And there's a pluton across the Strait to Kagalaska Island as well. And the pluton that was in southern Adak was 30 million years old. It is 30 million years, 31 to 34. And it's recently redated by Brian Jika, who's from Wisconsin. And so we had a time history. And okay, well, what about this Adakite? That turned out to be 12 million years old. So we're not really looking at recent stuff. But as long as there was recent stuff to be had, you didn't just say, I refuse, because I'm going to collect everything I can get my hands on. And that would be the big rock there. Okay, so we got help. We got help from, this is part of the story part of it. We got help from the Navy, certainly, because we had to have permission to go on the island. We had an NSF grant. That was maybe good enough for them, but not quite. We actually had to go to the senator's office in Anchorage to get okay from the senator. And the senators,
where did you get the samples there?
all over there, all over there.
Oh, all over there?
All over there, yeah. Actually, Steve Squires is one of the people who've been on the field to get those. But all right, so Stevens, a notorious individual, state senator, or no, U.S. senator from the state of Alaska. His executive secretary called up the commanding officer on ADAC, population 5,000 or so. Allender was the guy's name. He's a new guy on duty. And she says, these geologists are not going to have any problem coming out to ADAC, are they? I heard it. So, whoa, can't beat that. I mean, look, you got to have the senator on your side if you're in the Navy, right? I mean, there's a lot of back and forth here. So he came out, and Tom Spittler, who's a Reeve agent, Revolution Airways, Tom Spittler said, we met, and he said, you should pay a courtesy visit, not to the CO, but to the executive office. Excellent. I forget his name, but a guy turned out to be trained as a mining engineer in Montana. And he starts out with a memorable phrase, you may look upon me as the godfather of ignorance. So we got along with him just fine. Yeah. And there are various things that happen, just in getting to the sampling kind of thing. Casatoche Island, mentioned at one point, Casatoche is just down the way. It's a no protected shoreline. It's just the volcanoes, poking out of the Bering Strait, actually. And not the Bering Strait, Bering Sea, Pacific, actually. It's in the Pacific side. And so we went out there and had a devil of a time actually leaving the island, because it's easier to get onto an island if you have a skiff than it is to actually leave the island in the same skiff, because the swell comes in. It keeps wanting to deposit you on the shore. So anyway, I was wondering what Doug really thought was happening there, but we won't, you know. I mean, he was a very stoic guy, right? And there's a picture, which is somewhere, of his concerned look as he's looking out into the Bering Sea, wondering how he's going to get back. We had survival suits, so we could wade out. But then you got to get into the skiff. Yeah. Anyway, that was that. And there are innumerable kinds of stories having to do with that. Banishing Steve Squires from the cabin that was in the Southern Aid Island, Hidden Bay, for smoking a cigar. Well, come on, get out of here. This is really small. Yeah. Turns out that was the day that my son Alice was born. But we'll leave that aside. So we and surrounding islands went around, and just as an exhibit A anyway, these are the sea rations that were put there on Kanaga Island, including cigarettes in the big one, and you can't really read it too well. And this one has some cocoa powder and I don't know what else. I can't imagine that you could exist on that, but maybe. So this is part of the ADAC thing, and what else? I don't actually have. Okay, that does it. There's just a lot that happened in the region. I don't want to go further with it. Let's talk about this other one though, the one geochemical cycles. Now, see, the thing was being at Lamont and seeing a lot of water. There's a lot of water chemistry. A lot of stuff was being done that used box models. You have a reservoir of a certain volume. You have an addition rate. You have a subtractant rate. They're the same. They're kind of steady state. Right? That's what you do. It's your knee-jerk response. That was not the knee-jerk response of petrologists at all. They were worried about explaining that rock, not how it fit into some highly, difficult to say that you can make a reservoir out of the ocean crust. But you can, actually, right? And depending on what you want to do, you can use various reservoirs. And so this is in examples of that in these. Well, here I'll just say from Werner and Berner's book, there's of course the carbon cycle. There's cycles, but there's there's an Earth cycle too that involves mid-ocean ridge basalts, arc basalts, growth of the continents, destruction of the continents. Hey, we can put that in a box model. But no one was doing it, so why not? Just do it. See what happens. And carbonate silicate cycle, all that stuff was all prime territory for geochemistry, not for petrology. So in the 1980 paper, I said, okay, I'll just give a go at it. I did the total mass, and then also potassium. Try to track potassium around, track water around. Flash forward to 2010 and the present, and Dave Scholl and Franhuni did that kind of thing having to do with growth and destruction of continental crust. The growth being coming out at arcs, because the ocean crust basically disappears back down the mantle, and then the destruction being from the bottom, as well as sediment. So there's two ways to get continental material into the mantle. One is subductive, and the other is by compression, thicken the thing up and drop the bottom off. And so that's the second one is delamination. Subduction erosion is the third kind of process. So we say, oh, these are the processes. Now let's put numbers on these. When you do that, you get really inconvenient numbers. 10 to the 14th moles per deciliter. It means nothing to me. Actually, deciliters don't mean anything. But what happens is you find out when you do these preliminary kind of models that actually the number is very close to, at a reasonable density, a kilometer cubed per year, or at least a small multiple. So the ocean crust is forming 2.5 square kilometers times 6 every year. And you can count that up and find out what that is, and it's about 15 cubic kilometers a year, something like that, right? And so I said, well, look, there's a Dick Armstrong. Imagine heard of Dick Armstrong? He also died, actually, but he was always into the concept that the crust is being destroyed faster than it's forming, which is a deeply, troublesome thought to a lot of people. And so he didn't get very much. Yeah, 5 minutes, gotcha. So what happened was he said, well, it's equal, and so I called it an Armstrong unit. It's a cubic kilometer a year. And you can do that with anything, all right? So that was one of them. The delamination thing, well, we had an increase in citations of everybody around, and it's an operative process. You can see it on the wall in the 4th floor in the center. There's Sue's got an image of a delaminated block in the Andean context. So we would take it as being much more substantiated with that than a picture that would be drawn in 1993 without that. Okay, so let's just go with fun and games here. Fun and games is like going to lunch. We had a lunch group, and Don Turcotte really liked the lunch group, and Sid Kaufman from Industry said it's got to be 11:30 in the morning. So we all went to lunch, and there's a variety of politics in that group. It is by no means a homogeneous kind of group, and we talked about a whole lot of things, and Don thought that was really great. And he, in one of his citations for the Bowie Award, he actually mentioned specifically the lunch group. The second part of the picture there shows a conference. This may help to explain the Adakite thing. I think the conference was in Beijing. It was at 9/11. It was in October of 9/11. It's like a month after the World Trade Center. Ooh. So at any rate, DuPont was the guy who coined the phrase, or the Adakite was there, and I was there. There's a picture that shows it, and a couple of other, I'll call them gringos in this context. I don't know exactly what a Chinese gringo is. But so that one was pushed, and if you look at the citations, especially in the papers, it was published in a Chinese journal actually, with the three ways to make the Adakite. 75% of those are Chinese authors. Pay attention. Don't write for or submit to the journal. What the heck? We're used to that. I don't want to give advice without doing it. Okay. So let's see. There's one other kind of thing. This is the lunch group, and way back in days of yore, there was also a golf tournament every year. So I'll end with a golf tournament called the Turcotte Open. The Turcotte Open is a golf tournament. Was a golf tournament because Turcotte is an avid golfer. Jack Bird, Brian Isaacs were not so much. Jack Moore, maybe I could be all right. But at any rate, a Turcotte won the Turcotte Open that's recorded there, but it wasn't Turcotte himself, it was his son, Philip, who beat his dad because it was a scramble thing, so you had foursome. So 3 people might not even count, right? You could just do it all yourself. But at any rate, Philip won, and we had a barbecue out at Turcotte's. Okay. There's about 50 topics that I everything from cesium-137 and rust to, I don't know, all sorts of names, all sorts of stuff. Anyway, but that's the general, that's it. That's it.